Okay, so now we're going to find out what the derivative of cosine of x is. All right. Now, look, everybody should be able to do the first step. Can you at least do the first step for me? What am I going to write for the derivative? Pause and write your first step. Okay, hopefully you're back, and hopefully you wrote the limit as h approaches 0 of cosine of x plus h minus cosine of x over h. That's how we're always going to start a derivative statement. Okay, what else? What do I need to know now? I need to know how to break up this cosine of x plus h. So I had a formula for sine of a plus b. There's a formula for cosine of a plus b, but it's different. Do you know what it is? If you don't know what it is, look it up. Take a pause, look it up. All right, you should have found that cosine of a plus b is equal to cosine a cosine b. Isn't the internet wonderful? Minus sine a sine b. So, like, you know, I have to look this up every time. It's not important to memorize this formula. It's important to know that there is a formula and know where you can look to find it. So nowadays, it's the internet. In the old days, it was a book. All right, so now I can continue writing my derivative, okay? But I messed it up. I'm trying to talk and write at the same time. Okay, so I'm writing the derivative again because, again, I interrupted my flow, so I need to start again to write a complete sentence. So that's going to be limit as h approaches 0. Now I'm going to apply this formula to this expression. You do it. If you haven't done it already, pause the video and apply this formula to this expression. All right, hopefully you've done that, and you have cosine x cosine h minus sine x sine h minus cosine x over h. Okay, now we're going to do the same trick that we did last time. So the first time you see that trick, it's like, whoa, who came up with that? But all right, it's not the first time anymore. What do you think we're going to factor? Think about that next. What should we factor? How should we factor it? Okay, hopefully you took a pause and you figured out how to factor it. We're going to put this guy together with this guy, just like we did in the last derivative that we did. So this is going to be limit as h approaches 0 of cosine x times cosine h minus 1. That's these two terms. And then I have minus sine x sine h. So everything else is going to go the same way as we did it before. See if you can do it, the rest of it. Can you break it up and do the rest of it? Okay, so maybe you broke it up and did the rest of it on your own. Maybe you're just going to watch and let me do it. But, you know, it's just like watching somebody else do push-ups doesn't make you stronger. You got to do the push-ups yourself. So I'm going to break this up the same way that I broke up the other limit. So limit as h approaches 0. This is going to be cosine h minus 1 over h. And this, I'm going to have minus this time. And then so I'm going to have limit as h approaches 0 of a sine of x, and then times limit as h approaches 0 of sine h over h. All right, now we'll just do each of those limits. All right, so limit as h approaches 0 of cosine x. So the limit variable does not equal the expression variable. The h is not the same as x, so that limit is just cosine x. Limit as h approaches 0, cosine h minus 1 over h. That's the one we started with today. We know that that equals 0. Limit as h approaches 0 of sine of x. Again, the limit variable does not match the expression variable. You can think of it as substituting 0 for the h in an expression that has no h. So you just, there's the sine x. I put a 0 for every h that there was. Okay, and everything else I copied. And then this one, we know the value of this limit is 1. So there you go. The cosine x times 0 is going to be 0 minus sine x times 1. So surprisingly, the derivative of cosine x is not just sine of x, it's negative sine of x. Okay, you do not have to be able to do this stuff. You have to know that the derivative of sine of x is cosine x, and the derivative of cosine x is negative sine x. All right, you need to know those two things. Now, this is the beginning of a long list of derivatives that you are going to need to know. We're going to get another one in a minute. And what I want you to do first, before we start that one, is I want you to find out what the limit as h approaches 0 of e to the h minus 1 over h is. What is that limit? You make a graph and determine what that limit is, because we're going to use that for our next derivative, which is going to be the derivative of e to the x. And for people who really want to stretch their brains, okay, figure out this limit by looking at the graph. For derivative of e to the x, what are you going to write for your first step? What's your limit statement? How do you think you can break up that limit statement and factor something, get something that looks like this, and solve that? See if you can take a stab at that on your own. If not, it's okay. Just wait and watch. We'll do that in the next video.